density and hydrophilic qualities and how they affect the surface distortion. So let's start it this way. Let's say this has the perfect horizontal surface distortion. Now, in case of let's say low density and high density, this is the first determinant of the curvature. So, in case of low density, the object tends to, in any kind of object, it tends to be like this. In case of high density, it actually goes like this, right?
So it seems?
No, but it's like this, so you can't say this sinks, it's still floating. So, in case of high density, the object is always this is kind of exaggerated, but it's always below the surface. So whether it is hydrophilic or hydrophobic, there tends to be curvature like this. Now, in the case of low density, it tends to be kind of up, right? And then, if there's hydrophobic, it would be like this. In case of hydrophilic, it would be, as I explained earlier, sorry for the bad drawing, but it's like this.
Can you draw all the force diagram in these pictures?
Oh, the force diagram. Well, it would be easier to show my first of the PPT of the flowing diagram.
Yes. Including gravity and the buoyancy.
Yes. Yes, like that. In case of hydrophilic, if you go down to more slides, you can see also the hydrophilic. In case of hydrophilic, it's like this. Buoyancy. Yes.
What's the difference in the sunken depth of these two? What's the difference of the sunken depth between two objects?
Sunken depths?
How the lowest points of the object differs from the level surface?
I'm very sorry.
How much is sand?
Well, it's the very subjective point of view how much is sank. Well, in this case, it's above the surface level.
So which sinks more?
This would sank more, I guess. Yes. And I'm sorry, but to tell you the essence of surface distortion, in this case, there's in this case, the hydrophilic, so water tends to go up. Phobic, so water tends to yes.
Can you calculate how the contact angle in this case?
Yes.
Describe how did you calculate the contact angle?
Can I see the slide of contact angle? To tell you the brief explanation, we took a photograph, yes, and there you can see the curvature there.
So do you use photograph to calculate the contact angle?
Yeah, we use photograph and use the program to calculate the angle.
Well, in your first
yes.
This is buoyancy.
Yes.
And this is the contact surface tension.
Yes.
And this is the theta. So the vertical force will be the cosine of surface tension.
No, sine.
Okay, sine. Then couldn't you calculate using this equation the equilibrium of the force in this diagram?
Yes, that's why we actually calculated.
But you used the video. I didn't use
so we use this theta and use this theta into our equation and calculated the buoyancy, surface tension, and G.
Then what's the potential energy in this case?
You
mentioned about the potential energy between two objects.
So what I'm saying in this kind of concept of potential, it would not be really potential energy. What I'm saying is like this kind of potential. So I'm saying it's just to explain an easier concept way. So this can be thought as potential.
So there's no quantitative model for the energy stored in the water surface or something like that. So there's no equation or quantitative model.
You mean the whole kind of equation for interaction force, which I calculated.
Energy stored in the water surface.
But can I see the attractive force? Measurement of attractive force. To tell you like the final answer, we do not have the actual equation of the force, but I guess this would actually.
Also, you differentiate this and get the potential energy.
Can I see the next slide? We in case of differentiation, I think you misunderstood it. Integration. Since we differentiated this curve and got this curve fitting. Yes, it was very similar.
Can you quantitatively describe the magnitude of the distortion, such as how much the surface is distorted?
How much the surface is distorted in case of
as the density or the hydrophobicity differs? Do you have any equation or?
I don't know why you keep obsessive with equation, but in case of density, I have totally proved with the last 3 slides of the video that in case density changes, these 4 kinds of view will perfectly explain this phenomenon of curvature.
I'll skip the next question. About the contact angle.
Yes, contact angle.
In your first experiment, contact angle was like this, theta.
Yes.
Right? But when you use styrofoam ball, it is pure.
Yes.
So the contact angle is like. So by the definition of contact angle, you mean is it like this or like this? What is the contact angle in this case?
You mean in a hydrophilic case?
In the sphere, when you use sphere.
Yeah, in a hydrophilic case, it's like this, right? Not this. And in case of a very sphere, in case of this sphere, we cannot really get the picture of the angle, right? Because with the photo, it's very hard if it's not actually square or has some kind of square. So we cut this styrofoam into a square, and it was seen in another slide, and we calculated that way.
Isn't there a difference in the value in the contact angle if you use this method?
No, because it's the same density, right?
But it's same density, but the reference is different. The reference of this case is vertical to the contact side, but this picture is wrong. I think instead of that one. So the contact angle is like this.
Yes, I suppose. In your point of view, it would be like this.
And how the strength of the force differ when the density change?
How will the
strength of the force differ when the density change?
How will the strength differ if the density change? As I've said, as the mass increase, there tends to be bigger interaction, right? So the more it gets deep, can I have an eraser? Well, anyway, I'll just draw this. So the R, you remember that I said R is pretty much similar, right? So if the object is more deep, so there will have more contact angle, then it will have more force. What
about the case of the hydrophilic when you use styrofoam? When the density increases, will the force increase in the same way?
If the density increase? I guess you kind of misunderstood. In the hydrophilic case, it's this, right?
Yeah.
If you increase the density, as I did with the coin, the curvature tends to be very flat, and in the end, it's like this. So in this case, it would actually decrease because if the curvature is like this, there's no interaction.
So then, what would be the
Okay. For this question, the opponent takes 7 minutes to summarize.
In this debate, we try to model the exact quantitative model for the force, but the reporter keep addressing that the quantitative model for this case cannot be found, and he was only investigating about the trend and the direction of the force. I believe the key question, the question tells us to investigate about the mechanism of the problem, and I believe that would include the magnitude of the force which changes the contact angle. And in this case, I believe the reporter failed to exactly give the quantitative model for the strength of the force, and he also failed to give how much the R would differ as the contact angle change, and that the answer was not given the extent.
Okay, thank you for both. And the reviewer, please feel free to ask questions for both before and the opponent.
Thank you for the reporters and the opponents for leading an inspiring discussion. I would just like to ask some questions. First, to the reporter, what exactly creates the attraction of the repulsion between the molecules? Could you explain by explaining what is the horizontal force that acts upon the floating objects?
That would be two questions, right?
Yes.
Interaction. This interaction would be quite chemical, not, well, it can be also explained in a physical way. But in case of particle, there's water, right? Water is polar, right? In case of hydrophilic, it tends to be more polar, so polar, and there's interaction.
Yes.
And in case of horizontal, you mentioned the horizontal force. And I explained in my PPT and that there's three forces: gravity, buoyancy, and surface tension. And the only force in this mechanism, horizontal, is the part of horizontal of surface tension. Yes.
But according to the flotation system that you mentioned in your report, the surface is asymmetrical. So what exactly causes a horizontal motion?
Oh, you mean in case of this?
Yes.
So I'll explain again. But if the distance between these two objects is 2r, there's no interaction. There's no moving.
Yes.
But if there tends to be, if the curvature actually meets,
yes,
it tends to go down, right? In case of hydrophobic, okay. In case of it tends to go down, then the theta will decrease, right?
Yes.
If the theta decreases, the cosine theta of the surface tension will increase, right?
Yes.
That's why there's more horizontal force, and there will be attraction in case of hydrophobic.
Okay, but in that case, so you're saying that the imbalance in curvature by surface tension, because of the angle changes, there is horizontal motion.
Yes.
But here's a more fundamental question. Why does surface tension act parallel to the interface of water and air? Why does surface tension act parallel?
Acts parallel?
Yes.
Surface tension acts in diagonal way.
No, I mean...
diagonal way, and it has horizontal force.
So, what exactly is the direction of surface tension?
Surface tension, I wish I could have a great draw a picture, but let's say, in case hydrophobic, there will be curvature here, right?
Yes.
So in case the surface tension, it will be all like this way.
Yes.
So, there will be, yes, yeah. In this way, all the surface tension going around.
Okay, so this is a question for first the opponent and then the reporter. So, do you think that buoyancy would always act vertical in the vertical direction, even in the case of surface deformation?
Yes, the buoyancy is defined always normal to the direction of the sink.
Okay, and thank you and the reporter.
Explain again, because
well, the direction of buoyancy is always vertical.
Yes.
Okay, thank you.
Reviewer, please take a couple of moments to prepare for your final report.
I would like to start my review. So, good morning, ladies and gentlemen. This is Doyoung Kim from Team 혜움나래, representing Korean Mandarin Leadership Academy, and here I present the review for problem number 6, drawing pins. So, upon the point of the reporters confidently deliver the theoretical concepts and the properties that act on the object. However, the reporters lack both qualitative and quantitative approach to explain the phenomenon, which I will explain later on in the missed points. And also, he failed to control the variables, as the opponents mentioned, because their density and the weighting properties shown in the same time in experimentation. And also, he lacked explanations about the experimental setting, repetitive experiments, and errors. No thorough analysis was conducted on this part. And as for the opponents needed to more confidence in asking the questions on the theoretical background. And also, he kept questioning about the quantitative model to the reporter, in which he did not even create. And finally, he did not point any experimental accuracies and on the points that relate to the experimental settings or the experiment or the accuracy of the data itself. So here we move on to the discussion points in the theory. First, the opponent asked what happens if both the weighting properties and the density was changed. And on the side of the reporter, the insufficient answer was given. And also, he asked why the surface deformation occurs, and the reporters replied by saying that hydrophobic and hydrophilic properties and density was what affects the phenomenon. And this was a good reply on that point. And also, on the side of the opponents asked if there any quantitative model to explain, and the reporters replied there wasn't. And so the crux on the side of the theory is as follows. So the reporters emphasized the tendency and trends, while the opponents demanded a quantitative approach to the problem. So to this research. So there was not much of a discussion going on to the heart of the problem. And also on the side of experimentation, the opponents asked questions like changes of the mass of a coin or measuring the contact angle, but insufficient answer was given on the first question, but while a sufficient enough answer was given on the second. But what could have made the discussion better is that there was little discussion about the experimental setting, the data acquisition method, nor the accuracy. So let's move on to the missed points of the problem. So, if we read the problem statement, it says to clarify the attractive force and the repulsive force that act upon the object. So, we need to consider the forces that act on the problem, which the reporters and the opponents tried to consider. But exactly what, ladies and gentlemen, create this horizontal motion? Because both sides failed to qualitatively or quantitatively explain what exactly is the cause of motion. And also, both sides replied that buoyancy force actually always acts upwards. While this might be true or not, they needed to justify this statement by drawing the constant pressure lines upon the water layers, because buoyant force is caused by the difference in pressure, and it needs to be given if the pressure distribution would be same as that of a flat surface. And also, the direction of surface tension was not very well explained by both sides. And also, the second misobjective lies at the very heart of the problem, to investigate and explain the phenomenon. And here, as I've mentioned, what exactly causes the imbalance of the deformation? Both of the sides failed to mention this very basic question. And finally, onto the experimental setting, they did not mention how they control the turbulence on the water surface, which might affect the motion upon the floating objects. And finally, they needed to consider a contact angle hysteresis, the angle change that might be created on the surface of water. So we needed to be clarified if contact angle was always kept constant in this situation. And this is the end of the report.
Thank you, opponent and reviewer, for very many questions regarding this problem. Except for the fact that reviewer had some distortion of truth. Now, in this case, most of the things reviewer mentioned were also mentioned by opponent. I will address directly to the reviewer's question, reviewer's points. Now, reviewer said that I lacked control of variables, density and mass. But in this case, in case of Teflons, as you see, the mass increase and density is the same, so it's controlled. Now, he also asked for, in case of opponent, he asked for R, the relationship with R and contact angle. And I explained again and again that R, while it is quite similar, the contact angle increases when the mass increase. Also, the reviewer mentioned about the wetting property and density change was not very clarified by me. But those four diagrams just directly explains the question. And yes, and he also mentioned about the direction of surface tension, which I correctly answered. And he also asked about what